Hi, good evening, Adil.
Good evening.
Okay. Okay, so my screen is visible, right?
Yes, yes, yes.
Okay.
The syllabus for the quiz is still week 5 to 8 or week.
Yeah, syllabus will be week 5 to 8,
Okay,
and there will be someone see the concept, the whatever we have covered, like week 1 to 4. Concept will be like maybe used, but mostly will cover from week 5 to 8.
okay. Week 9 is not there.
Week 9 is not there.
Okay, okay. Thank you.
And there will be like 5 true false question will be there. True false question will be there, and there will be 9 MSQ, MCQ, and NAT will be there. So 5 are like simple true false kind of things. Like if you know the things, you can like just true and false.
Okay,
And uh, at this 9 MCQ, like there will be, I think, three from 3 or 2 from, I think 2 or 3 from KMF,
okay.
and then one will be like half adder, full adders. This, sorry, I'm not exactly remember, but okay, let me 1 second. Two, and yeah, there will be from week 5. Week 5 there will be 3 KMF question, and there will be one uh, like full adder, half adder questions, full adder, half adder questions, and one will be like combinational question. And then there will be 7 and 8, right? So there will be some question from timing diagram. There will be week 7 and week 8. There will be timing diagram question, and there will be like design based question, some design based question. Right. So there will be 5 MCQ, and there will be 9 MSQ, uh, MCQ, and NATU. Right. So I'll suggest like uh, whatever that practices like assignment question, graded assignment question, just solve like week 5 to 8. I think week 6 is it's like tutorial video only is that, so there is no practice and graded assignment. So just solve week 5, 7, and 8. So just solve with like on your own without seeing solution. That will be good.
Excuse me, sir.
Yes.
I just wanted to confirm one thing. The syllabus is up to week 8 or just from 5 to 8? So will 1 to 4
See,
be there? Or?
it will be week up to like week 1 to 8. So mostly we'll focus on week 5 to 8.
Okay, okay.
Uh, and Prithat, if like your week 5 graded assignment marks has been updated.
Yeah. The updation has been done, but I'll still need to cross check if the current, like whatever is showing, is it correct or not. So I'll cross check that and let you know. It has been
Uh,
updated. That is correct.
okay, okay. Okay, so any doubt from like any doubt up to week 8? This will be like structure of the quiz too. Like this true false question will be like from week 7 to 8, week 7 and 8. Like it will be like simple, like uh, when it's toggle states, like kind of that. In DLS, when it will be like memory hold, kind of like that. So it will be like simple.
Okay. True, false. So it will just be two options then. True or false. That's it.
Yes, correct. There will be two options, true and false.
Okay.
So there will be true and false. You have to tick one. Like kind of MCQ, there will be two options.
Okay. Okay. Yeah. Got it.
Okay, so let me solve some question that will be good. Okay, consider the function given below. App ABCD, summation of 0 to 4, 5, 6, 7, 8, 10, 12, 13, 14, 15. If you want to implement the minimize expression using only two input NAND gates, what is the minimum numbers of NAND gates required given inputs A, B, C, and D along with their complement, right? So we have complements, we have inputs like A, B, C, D, and with their complement, right? So we have to find the minimum numbers of NAND gate required, right? So let's draw the Carnot map. Right. 1, 2, 3, 4. And this will be 0, 0. This will be 0, 1. This will be 1, 1. This will be 1, 0. This will be 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 9, 11, 10, 12, 13, 15, 40, right? And it's given 0, 2, 4, 5, 6, 7, then 10, 12, 13, 14, 14, and 8 also, right? So what is the minimum numbers of NAND gate required? You can see, you can find that POS because like if you want to find POS, you have to group only that things, right? That things. So if you find the POS, what will be POS? Suppose this is A, B, and C, D. What will be the POS? Anyone? Richadeep, what will be the POS? Okay, so POS will be
B plus D complement.
okay. So yeah, it will be like 0 and 0. So it will be B plus, and it's like yeah, B plus D complement. Okay, so this is the okay. Okay, B plus D complement, right? Suppose this function, if you want to implement in the NAND gates, how many NAND gates is required? So what will be NAND gates outputs? If it's X and if it's Y, it is X dot Y bar. It will be, if you find like De Morgan's law, X bar plus Y bar, right? So if you want, so how many like NAND gates is required, right? So you can implement like that. So suppose B plus D bar, right? So you can implement like that. Suppose this is an NAND gate. This is an NAND gate. You can implement. You can see that all along we have input A, B, C, D along with their complement, right? So we have input A, B, C, and D along with their complement. So we can use complement also, right? So yeah, so we can use, yeah, it's B complement, yeah, it's D, right? So what will get output? We'll get
B plus D complement.
B complement plus D. So we'll get B complement dot D, right? So if you apply De Morgan's law, you will get B plus D complement. So it will require only one NAND gates. This is the, I think, which 5 graded assignment question number 10 after the updation.
Yeah, yeah.
So this type of
Sir,
question
so,
may
the
come.
B bar is already given.
Yes,
B bar already given.
you can see that we have uh, inputs, given inputs A, B, C, and D along with their complement. So we have inputs A,
Okay.
B, C, and D along with their complement.
Okay.
Yeah. Okay. Now let's. I think this question we have solved
So
in the.
just one doubt. If nothing is mentioned, then we'll just take A, B, C, D.
Yeah.
That's all we have.
Yeah. If nothing is mentioned, then you have to take A, B, C, and D.
Okay, okay.
Okay. So I think this question I have solved in the one of the live sessions. So just we can solve this type of like what we can say, like I will give some scenario and you have to implement the Carnot map, then you have to implement the logic circuit, right? So these types of question will be may come in the exam. So just solve that question, that will be good. Okay. Now, and this type of design based question will come. So if you want, if we want to implement a circuit where the output changes from 00 to 01 to 11 to 00 using JK flip flop as shown in the figure below, what should be the correct expression for J1 and J2, right? So you have to find the J1 and J2, right? So for these types of questions, how to solve that question? So there will be present state, right? So this will be the present state, and there will be next state and next state log, next state, like whatever the output, right? So this will be Q1, Q2, then Q1 next. This is Q1 and this is Q2 next. And what will be the J1, K1, J2, K2, right? Okay, you can see that 0, 0, 0, 0 changing to 0, 1, right? Then 0, 1 changing to 1, 1, right? It's changing to 1, 1. Then 1, 1 changing to 0, 0, right? And then, yeah, it's then repeated, right? So how to solve this kind of question? Okay, so now if you remember the excitation table, so what is the excitation table? So excitation table. So Q output and the input. This will be the present state, and this is the next state. And what will be the Jn, and this will be the Kn, right? So it will be 0, 0, 0 to 0, 1. Whatever the value of Jn and Kn, it will be 0 and don't care. Then 0, 1, it will be like 1, don't care. And for 1, 0, it will be don't care 1, and for 1, 1, it will be don't care 0, right? So you can see that we are changing from 0 to 0. So what will be the value of J1, K1? 0 to 0. You can see that 0 and don't care, right? So you can write 0, don't care, right? Now we can see that 0 to 1, right? You can see that 0 to 1. What will be the J and K? 1, don't care, right? So you can write 1, don't care, right? Now we can see that 1 to 0, 1 to 0, 1 to 0, it will be don't care 1, right? So it will be don't care 1, right? And for similar, like you can put for the J2 and K2. So J2 and K2, you can see that 0 to 1, what will the 0 to 1, it will be 1 don't care. 0 to 1, it will be 1 don't care. So 0 to 1, 1, 1 don't care, right? Now we can see that 1 to 1, what will the value of 1 to 1, it will be don't care 0. So it will be don't care 0. Now you can see that 1 to 0, 1 to 0, 1 to 0 don't care 1, right? So it will be 1 to 0 don't care 1, right? So don't care 1, right? Now we can find the, we have to find the J1 and J2. So you can find the J1 will be you can see that J1 is, if you find the SOP, J1 will be Q1 bar. So this is the J1 will be like this. So we have to take this, right? It will be Q1 bar, Q2, and what will be the value of J2? So J2 we have to find that things. So we have to find the Q1 bar, Q2. So it will be J2 equal to Q1 bar, Q2 bar. So answer will be this. Okay. So everyone understand how to solve this type of question? You have to remember the excitation table at JK flip flop and the D flip flop. D flip flop is easy. For JK flip flop it will be, you have to remember. Any doubt in this problem? Okay. Okay, that consider that circuit shown below, considering up to D flip flop and one NOR gate. Identify the correct sequence of the counter state, right? So you have to find the correct sequence of the counter state, right? So you can see that there are two D flip flop. So you have to find the current sequence. So you can see that what will be the D1, it's given. So Q1 next is given equal to Q1 plus Q2, and Q2 next is given Q1, right? So thus draw, right? So Q1, Q2, Q1 next, and Q2 next. So if it is start from like initially D1 is set state, so D1 set means 1, and D2 is reset state, 1 is 0, 1 0. What will be the value of Q1 next? You can see that Q1 plus Q2, then NOR. So 1 plus 0 equal to 1, and complement it will be 0, right? And Q2 simply like Q1, so it will be 0 1. Then after that 0 1, again it will be uh, 1 plus 0 equal to 1. Then no, it will be 0, and it will be 0. Then it will be 0 0. So it will be 0 or 0 or 0. It will be 0. It will be, and again complement it will be 1, and it will be 1 0, right? Then 1 0, it will be 0, and it will be 1, right? So you can see that it's like cycling. So it will be 1 0 0 1 1 0 0 1 0 0 1 0 0. I think this is the correct option. So using jacket flip flop, this type of question may be there. Okay. Any doubt in this problem? Okay. So next question is, a circuit is formed with 2D flip flop with synchronous clock denoted by D1 and D2. Outputs are Q1 and Q2, right? For the next state, logic is given by D1 equal to Q1 bar and D2 equal to Q1. Which of the following is absent in the steady state, right? So you have to find the which of the following output is absent, right? So D1 is equal to given Q1 bar and D2 is equal to Q1, right? So let's state D1, so it will be Q1 and Q2, again Q1 next, it will be Q2 next. Suppose it's start from, so you can see that without like writing truth table, you can also answer, because you can see that D1 equal to Q1 bar and D2 equal to Q1, right? So it's opposite, right? So 0 0 it's not possible and 1 1 is not possible, because its output is opposite, right? So you can simply answer 0 0 and 1 1, right? So you can draw truth table also, otherwise you can also without like drawing the truth table, you can answer. Okay, so I'll discuss some regarding half adder and full adder, right? Okay, so this will be half adder. So suppose A and B and sum, and this is sum and this is carry. So on A and B both are 0, sum equal to 0, carry equal to 0, 0 1, sum equal to 1, carry equal to 0, 1 0, sum equal to 1, carry equal to 0, and 1 1, it will be sum equal to 0 and carry equal to 1. Suppose if you want to implement, what will be the sum? Sum equal to, you can see that A bar B plus A B bar, so simply A or B, and what will be the carry? Carry will be A B. Suppose you want to implement, so using get, so you can implement like that. This will be A and this will be B, and this will be sum, and this will be carry, right? Okay, now uh, what is full adder? So full adder A B C 0 1 0 1 0 1 0 1, right? This is sum and this is carry, suppose, right? So on it will be sum equal to, this will be 0, this will be 0, and this will be sum equal to 1, this will be sum equal to 1, and this will be 0 1, and this will be 1, this will be 0 1, and this will be 0 1, and this will be 1 1, right? So we can write sum equal to, people observe, sum equal to A or B or C, and carry will be summation of 3 5 6 7, summation of 3 5 6 7, right? So you can write it will be 0 1 1, right? So it will be A bar B C, then 5 equal to A B bar C plus A A B 110 A B C bar plus A B C, right? So it will be A or B. This is C plus AB, right? Suppose if you want to implement full adder using half adder, right? So what will be the circuit? This will be the OR gate AB, and this will be again OR gate, and this will be seen, and this will be sum, and you can see that A or B C, right? So this is A or B and this is C, right? So you have to NAND gate, and this is AB, right? So you have to take in one more AB, and I can just put this will be carry. So this will be the implementation of full adder using half adder. So any doubt?
Yeah. Hello.
Yes.
Yeah, I had a doubt regarding this full adapter. I'm just trying to search for that. I had posted that on Discourse.
Okay.
Basically, so for example, in logic gates, we can have two input gates, three input gates,
Mhm.
whatever we want. So in adder, I wanted to ask if we can add multiple. So if instead of so here it is a two input, right? I mean, we're
Mhm.
A and B.
Mhm.
So for example, is it possible to have a three input full adder wherein you have A, B, C, and then carry in?
You can also do that. So we have implemented full adder using like half adder, right? This is a circuit of
Right.
half adder. So we have implemented using like that. So you have implemented. Hello.
Yeah, yeah.
Okay. So that's like that. You can also implement using kind of that.
Okay, but there I mean, you are integrating multiple adders together to
Yeah,
get that.
correct. Yeah,
So
correct, sir.
I'm saying, is it possible to have a single adder itself which can add multiple? I mean, more than two bits. Is that something that can be done, or it is not? How it is
It can
designed?
be done. You can use like three input jargon, right? So it will be some you can
Okay, yeah, that is for summing. Okay,
uh, and
so
for
it will act like a half adder then.
uh, and carry for you can for carry you can also implement like you can design your circuit.
Okay, okay,
Uh, and there will be carry look like carry look adder, right? So you can just see what is carry look adder and all the things
okay.
like that will be good because one question will be come from full adder and half adder. So carry look, I think.
Okay, okay.
Yeah.
Do
Okay.
we have
So
any mock tests or anything for
uh,
this?
no, like just solve all the practice assignment and the graded assignment is sufficient for you.
Okay, okay.
And there will be triple calculator and all the things. Just see all the slides. That will be good.
Sorry, there will be triple what?
Uh, repel
Oh, sorry,
calculator.
ripple carry
Repel.
adder. Yeah, yeah. Okay.
So there will be 2 bit, 4 bit triple calculator.
Sir, I think week 8 assignment solutions have not been given yet.
We have released. Just check.
So, I'm talking about practice assignment.
Yeah, we have released practice assignment.
Okay, okay. I'll refresh and check. Maybe as of now it's not showing, but okay.
And I think we have released. So let me
Oh,
check.
okay, okay. I see. The graded assignment folder, you have two week 8 documents. Okay,
Oh,
that is
sorry.
practice assignment.
I'll replace.
Okay, okay, it's fine.
Okay.
The PA is in the GA folder along with the GA as well. So it's fine. It has
Okay.
been
Okay.
released.
Uh, okay. I'll just change the folder. Okay. So quiz 2 will be simple if you solve all the practice assignment on the graded assignment, and it will be very simple. Don't worry. Just a little bit tricky will be there. You have to think how to solve that question.
So I expect we'll have similar types of questions at minimum number of NAND gates once again.
It will be one kind of question of the minimum number of delegates. So
Yeah.
if you understand this logic, you can able to answer.
Okay. Okay.
So not it will be very difficult. Okay, then thanks for joining. Have
Thank
an
you, sir.
like all the best for exam.
Thanks.
That second problem that you showed,
This problem.
I think this was wrong in the graded assignment.
No, this is I think practice assignment, right?
Yeah, I'm not sure.
Yeah, this is practice assignment,
Okay, okay,
and I have solved in the I think one of the live session.
okay, okay.
So